Alright, let's get going. Change this there. Boom. And here we are. Welcome back, everyone. We actually have before I get started, we have an update to the Swift Playgrounds app. We got our menu all down here on the left side instead of going on the big drop down on the top. Gave me a little bit of a startle. I didn't know what I was doing when I first started, but we have some exciting news. We are officially on our last season finale video of the Swift Playgrounds course, the Learn to Code 1 course. So this will be our last video. We have 3 more lessons. Hopefully we can get them done. They might take a little bit longer, but I'll try to go fast. Pretty crazy, pretty exciting. So hope you guys had a great Thanksgiving. Well, let's get to it. So we left off with adjusting our algorithm, basically to make it more usable in multiple situations. So instead of always turning right, oh, that is loud. There we go. We basically made it more reusable, I guess, so we could use it in multiple situations. And now we're at conquering a maze. So let's, whoops, I exited out of that. Wasn't supposed to do that. Here we go. It is loading. There it is. All right, conquering a maze. So you gotta just click the menu button. That's what it does. All right, so all this loads. Let's read the description. Here we go. All right, the goal. Use the right-hand rule to navigate through a maze. In an algorithm that follows the right-hand rule, works well for solving simple puzzles. But did you know that you can also use it to move through more complicated paths like mazes? For this puzzle, walk through the maze in your mind. If you always keep your right hand on the wall, you'll eventually reach the last gem. To solve the maze, adjust your algorithm from the previous page to navigate to the gem and collect it. Alright, so where is the gem? Gem's right here. Okay. This is interesting. So how do we get there? We want to go basically up the stairs and around, and then back down the stairs, and then all the way around here. All right, wow. So let's see here. So we're gonna use, are we gonna use right hand rule? Start with the code from your previous page by copying and pasting, or if you want a challenge, start with all new code. No, let's copy and paste. Copy and paste. So we're going to, why is it just so loud? Turn this down. Turn it down a little bit. There we go. That's a little better. Okay, I'm going to copy this. Go to the Conquering the Maze. Tap to enter code. Close this thing so we have more room. Paste. Okay, so we copied the new code. On previous page, copy and pasting. Might I add, I know we're getting a little bit of a slow start. Copy and pasting code, huge key. Do that all the time. Don't be ashamed of it. Alright, so let's see. If you want a challenge, start with all new code. No. The second step, adjust your code so that your character follows the right hand rule through the maze until reaching the gem. So before we even edit this, let's just run it and see what happens. I'm just gonna run faster and just see how he does this. So he's going. Wow. Okay. So it got it. It's not the most efficient. If is blocked right and blocked, turn left. If is blocked right, move forward. Else turn right. I think you're just gonna keep going. Okay, interesting. So he was able to actually collect the gem. They're just pretty incredible. But we were kind of in like this infinite loop. And it didn't really stop ever. So we collected the gem. I wonder if, let's see if we can make the smallest, slightest adjustment ever. We're just gonna collect the gem instead and not turn around. Think it'll work? Maybe, I don't know. He's gonna take a right here. And he's not gonna be blocked on the right, so he's gonna take another right. He still turned. What did he do? Why did he turn left? Stop it. So he collected the gem, and then he turned left. Oh, because he was blocked on the right and blocked. So he turned left twice. Okay. So while he's not on a closed switch, so I don't know if that's what we really want. I think we just want to run navigate around wall. But we still need the while, right? So you don't need toggle switch. So let's see. Let's do this. While is, can we do like not on a gem? While is not is on gem. Navigate around wall. And if it is on gem, collect the gem. That's what we're gonna do. Oh wait, hold on. Whoops. So, and then, so we're gonna have this while loop. Can I select this, please? Thank you. We're gonna try this. Copy, please, thanks. So we're gonna make this an if statement. If byte is not on a gem, oops, navigate around wall, else if is on gem, oops, It is on gem. We're gonna collect that gem. Think this will work? I don't know. So we used our same navigate around wall. So if Bite is blocked on the right, aka he can't go to the right, or if Andy's blocked on the in front of him, he's gonna turn left. If he's just blocked on the right, he's gonna move forward. And if he isn't either of those, then he's gonna turn right and move forward. Correct? Yes. Let's run this. See what happens. Blocked on the right. What? Oh, we need a while. Dang it. Okay. If isn't gonna work. So while he's not on the gem. Oh no, the audio stopped. That's okay. While is not on a gem. Navigate around the wall. And then basically we're just gonna, if he's not on a gem, he's gonna run navigate around the wall, and then he's gonna exit out of that while loop because he will be on a gem, and we're just gonna collect the gem. Okay, let's do this without any music. I can't remember what all my. That's the baby crying. We don't need that. All right, so he's navigating pretty well. He's gonna go. It's a little bit of an inefficient route, but we're covering all of our grounds, making sure there's no gem there. You know. Hey! Oh man, I wish I knew my memes better. There we go. There we go. Rewind. Don't need it, but again. All right. So all we did was we did step one, we copy and pasted our code from the last exercise, and then we essentially changed the while loop to be, instead of switches, since there weren't any switches, we changed it to gems. And Byte was able to navigate around the wall function, was able to get him all the way to the gem, and then once he got to the gem, he collected that thing. So I'm trying to figure out if he's blocked on the right and is blocked. Turn left. Oh, so if it was just blocked, then he'd turn right and move forward. Okay. I was a little confused in the code I wrote, or we wrote, I should say, but I understand it now. All right, next one. The little text box says, wow, you really improved your coding skills by creating and tweaking your algorithm in these recent puzzles. You've created a powerful bit of code that will continue to work in new situations. Now that you've mastered solving a maze, see if you can generate algorithms to solve different scenarios. Exercise. Write your own algorithm to solve the maze. You've tweaked several algorithms so far. It's time to practice what you've learned and write your own algorithm from scratch. Sounds intense. Wow, look at this course. This is brilliant. Nothing like pulling out all the stops on the last couple exercises, huh? To complete the puzzle, you need to follow the path, moving to each switch, and then deciding, whoops, don't need that, and then deciding whether to turn right or left. Left or right, I switched those. To identify a pattern in the puzzle that lets you know which way to turn, walk through pseudocode in your mind for how to toggle the 6 switches and reach the gem. Write your code, testing and adjusting your algorithms as necessary. Whew! Alright, so we need to get to all the switches. So toggle the switch. So which way do we want to go? We want to go following the path, so we gotta go all the way through. Follow the toggles or the switches and then get to the gem on the final one. So what's the pattern here? We gotta move forward until we hit a switch. First one we take a right, then we take a left, then we take a left again, then we take a right, left. So that doesn't work. So we should say left, left, right, left. Ooh, I know the pattern. Okay. So, every time we need to take a right on a switch, we aren't blocked. If that makes sense. If anyone understands that. So, on this first toggled switch, or on this first untoggled switch, we want to take a right, and we have nothing blocking us from doing that. Every time we want to take a left on a switch, we're blocked in front of us. Or, yeah, essentially we're blocked in front of us. So we're gonna say, we're gonna have a while loop. We're just gonna go for it here. So while you're not on a switch, while you're not on a switch, we're gonna move forward until you are on a switch. So while is on, while not is on closed switch. I think those are closed, right? We're gonna move forward. And this might be in a big if loop. So while you're not on a closed switch, you're gonna move forward, and then once you get on a closed switch, okay, and then we're gonna say, we're gonna have an if statement. If is on closed switch, we're going to toggle switch. Okay, so now we have those two conditions met. And then, so what else do we need to take care of here? So if you're on a closed switch, you got to toggle it. If you're not on a closed switch, move forward. Here, we should update this if. So if you're on a closed switch and you are blocked, is blocked, then you're going to toggle switch, and that would mean you need to turn left. Turn left. Boom. Okay. And then let's see. Turn left, and do we need to move forward? No, because you wouldn't be on a closed switch anymore. So it would still do not on a closed switch. So now we need to factor in if on a closed switch and is blocked, toggle switch and turn left. Else, do we need to do else if? Just is on closed switch. Then we need to toggle switch and turn right. So you could do this, I guess, a couple ways. You could do else if is on a closed switch and is not blocked. Or we could do it this way where we're saying if is on a closed switch and is blocked. It'll do that condition first, and then it'll do the next one. So obviously the next one would be not blocked. But either way. Okay, so we have this if while is not on a closed switch. We want to move forward. And then okay, so and then if is on a closed switch and is blocked, toggle that switch and turn left. Else, if you're on a closed switch, if you're just on a closed switch, turn right. So I think we want to put this while loop in a function and trigger that function every single time we toggle a switch, or else we're not going to get in that while loop again. I believe. That's what I'm guessing. Function not on closed switch. Boom. And then we're gonna do this cool little boing thing. Nope. There we go. Okay. And then we're going to... Is that wrong? What am I doing wrong? Oh, wait. Sorry. There we go. What? Oh. Okay. Sorry. What is this thing doing? What does it want? Oh. 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 Sorry. What are you doing to me? Why are you doing this? Whoops. What's going on? Okay, close that error, please. Function not on closed switch. While is not on closed switch. Forward. What do I need here? I don't understand what it wants me to do. Oh, I'm writing function wrong. Sorry, it's just funk. I'm getting my languages mixed up. Okay, so we have this function not on a closed switch. And we're going to say, and this is going to run the while loop that's saying, while you're not on a closed switch, move forward. And then it'll get on a closed switch and exit out of that. And say, so we're going to start this by running not on closed switch, and then we're going to say if you are on a closed switch and is blocked, turn left and then run not on a closed switch again. We're going to just trigger this. Or could we just bookend it? No, I don't think that would work. Let's just run this and see what happens. Step through this thing. Step through my code. Move forward. Move forward. Oh, we're on a closed switch. Toggle that thing. Turn right. Run. Function again. Move forward. Move forward. We're on a closed switch. What? Oh, did it just end? Okay. Well, that didn't work. So let's do... let's see, how many toggles do we have? 1, 2, 3, 4, 5, 6. We have 6 toggles. So we could do a for loop and run it 6 times if we wanted to. And just do move all this stuff into this function. So while you are not on a closed switch, move forward. So we can do this, and then we'll do 4, 6 times run. Not on a closed switch function. Alright, let's see what happens here. So we're going to do this synchronously, or we're going to do this in order. So I guess it'd be asynchronously. So there's 1. Move forward. Move forward. Toggle the switch, turn left. There's 2. This isn't going to finish the exercise for us, but it'll be good to see it get all the way through. Do we have the... What's my... Nope. We don't want to rewind. Keep going, Bite. Keep going. Nope, we don't want that either. I can still adjust in my meme board. What's this one do? F4? Not doing anything. Oh, I like this one. Hey. I want to like the applause. On fire, kind of like that. This one's money. Okay. Funny. None in there. What's, I thought applause was like 1. Baby. Laughing, that's a good one, because Bite just stopped moving. There's applause. That's loud. Sorry, guys. Okay, so like I said, it didn't finish our activity, but we just need to add something at the end. So we do the for loop for all the switches, and it is, so we trigger toggle all the switches, and then we gotta just go. We can say, whoops. Say while Bite is not on a gem. While Bite is on gem. Move forward. And then he will be on a gem, and we're just gonna collect that gem. Boom! That should be all the code we need. That would be, 6, 7 lines of code. Alright, so let's run through it faster and just see if it goes. Let's hope it does. So he's gonna run through the for loop 6 times. Boom, baby! And we can do the for loop on this one because this course doesn't change. Look at all this. We're using while, we're using functions, we're using else if, we're using for loops. Boom, baby! Brilliant! Now you're creating your own algorithms from scratch. How cool is that? That's pretty dang cool. Alright, I know I'm going over, but we just have one more activity, so we are going to go. I mean, it's a season finale. What do you expect? It's got to go long, right? Okay, how hard do you think it's going to be? I think it's going to be pretty dang hard. We'll see. Challenge. Implement the most efficient algorithm to... I can't say algorithm anymore. I've been saying it too much. The most efficient algorithm to collect the gems and activate the switches. For the last challenge of Learn to Code 1, you'll test your algorithm design skills. There are many different algorithms you could use to solve the puzzle, and many different ways to structure your code. If you're not able to find a solution right away, that's okay. Coding often requires trying different solutions to a problem until you find one that works best. When you're ready, you can move to Learn to Code 2. Whoa, we're getting ahead of ourselves. So, let's look at this. Let's try to find an algorithm to solve this baby. We're going to be pushing 40 minutes. Okay, so every time you're on a gem, you're blocked. in the front, correct? So we can basically say move if you're on a gem, if you're blocked in the front. Let's just start typing. So if you're on, if you are, is on gem, and you are blocked, is blocked. Boom. What are we going to want to do? We're going to collect the gem and turn right, correct? And we're going to move forward. And that means you will be onto the next gem, and then you can collect that one too, right? So if is on gem and is blocked, that means you will collect gem, turn right, move forward, collect gem. So let's put this in a function. See if I can type function right. Bunk name. Let's go back to our earlier days. Collect dem gems. Boom. And in this function, we're just going to put this if. Actually, we should put the if statement. Let's see. Hold on. Yeah, we don't need this if statement inside of here. What am I thinking? Collect them gems. Goes right here. I wish I could reformat this somehow. Whoops. There we go. Alright. Now we're talking. Okay. So, collect dem gems function is going to collect the gem, turn right, move forward, collect the other gem. So that collects the two gems. You're going to say if is on gem and is blocked, then we're going to run collect dem gems function. Okay, so if you are on the gem, if byte is on the gem and is blocked, collect them gems. Let's see here, and then we're gonna move forward. Do we always move forward 3? 1, 2, 3. No, that one was 4. And then we're gonna move forward. So we're gonna collect them gems. If is on a gem and is blocked, collect them gems. Let's see here. What's the best way to do this? We could just trigger. Let's see. I'm trying to think of the best way to do this. I don't know if this is the most efficient way. So we're going to move forward. And run. Collect them gems. Ooh, we're going to put it in the collect them gems function. So we're going to move forward, move forward. He's gonna collect the gems, and then we're gonna say while he's not blocked. While bite is not blocked. Basically, move forward. Okay. And then, when he is blocked, he'll exit this while loop. And then we're going to want him to always turn left. Because this way, now he will be on the switches. And then we're going to have him turn left, move forward. And then the switches will always be after he turns left, moves forward. So we're going to toggle the switch, move forward again, and then turn left, move forward, toggle switch, move forward, toggle switch. Okay. And then we're going to have him move forward again. Yeah, then we're gonna have another while. While. Why do they capitalize while? While is not blocked. Is not blocked. Move forward. And then he will be blocked, and then he's gonna turn right. Turn right. And then we'll be back in the same position. So let's see. And we can run this 1, 2, 3, 4 times. 1, 2, 3. But he's, yeah, that's fine. And then you're just gonna hit the rocks. I think we might need to make some adjustments, but so we have this big function called collect them gems. We should rename this because it's not really collecting. I mean, it is collecting gems. We're gonna do, this one's gonna be called function collect everything. Okay, terrible function name. Usually you want to name something that here, well, I should do best practices. Collect gems and toggle switches. No shame in the long function name. Okay. We're gonna delete this, sorry. So we have this big function. So we're going to run this function. So we're gonna say for loop, we want to run it 4 times. And the code in there is just gonna be this collect gems and toggle switches. What do you think is gonna happen? Let's see. Run my code. Move forward, collect the gem, turn right, move forward, collect the gem. Go forward while you're not blocked. Thank you, Bite. You're doing great. I should have stepped through this. I don't know why I didn't. Toggle that switch. Oh my gosh, what did I do wrong? Stop it. Stop it. Okay, so he got onto the turn left, move forward, toggle switch. Oh, I didn't turn him. Whoops. So he's gonna turn left, move forward. Let's turn him left again. Key command that we missed right there. Okay. Is there a laughy? A laugh? There it is. Thank you. Turn left, move forward, turn left again, then toggle switch, move forward, toggle switch. Okay. Let's run through this, only faster this time. Try number 2. Alright, so this whole function toggles 2 switches and collects 2 gems. Now we're going to do it again. We're going to go till we're blocked. Toggle them switches. Boom. Okay. I'm interested to see what happens here. I wonder if it gives us credit for this. Oh, it toggled it. No. Oh. Oh. Okay. So this doesn't change every time, but since we're writing algorithms, we want these to be reusable. We should make it reusable. So we should say if block, if condition. So let's say if is on close switch. Run all this stuff. And then, so if you're on a closed switch, then you're gonna run this and toggle all them switches. Else, if you're not, else if, what do we want him to do? So he's gonna move forward. Else if, I guess he could still turn left. Okay, sorry, I need to redo this. Need to redo it. We're going to copy this, put it above this, boom. So they're always turning left, moving forward, turning left. So we're always on the switch. If you're on a closed switch, you're going to toggle that switch, move forward, and toggle the switch. If you're not, you're going, if you are on a open switch, I don't need the else if. Otherwise, you are just going to nothing. You're going to do nothing. That's what I'm going to do. Do nothing. Okay, now let's run this. We had the whole thing and then we just blew it on the last switch. How unfortunate. Alright, here we go. Season finale. Let's go. Wrong thing. Darn it. I need to remember that one. That's F5, everybody. Alright, Bite. Come on now. Let's go! On fire. I'm heating up. We're heating up. What's the... No. Is it F3? Nope. I want the air horns. Air horns. That'll keep the money coming. Keep the money coming. Nope. Where's the air horns? There they are. Let's go. Turn the money. Nope. Turn the money off. Turn the fire off. Alright, everyone. Outstanding work. You've just completed Learn to Code 1. Time to shout out I'm a coding master and do a little dance. We kind of already did that. You've come quite a long ways from writing simple commands. Yeah, look at this. Look at what we just wrote. The last section is crazy. You can now write intelligent algorithms using for and while loops as well as conditional code to make your code adaptable to different situations. It's time to start the next part of coding your journey, Learn to Code 2. Now, they are getting a little bit ahead of themselves, I would say, in my opinion. So yes, we did just finish Learn to Code 1. here on STEM Effects Streams. I don't know, STEM Streams, I should say. I don't know what we're gonna do next. We're gonna enjoy this weekend. Gonna brainstorm. Let me know if you guys have any requests. There's a Twilio tutorial thing that I think would be really sweet to do. So maybe we'll do that. I got some things on the list. I don't know if we're gonna jump straight into Learn to Code 2. We'll do that maybe at a later date, get back into it. But we'll try something else. And I'll keep you guys posted. But for now, good work. Thanks for staying with me. Shout out to my little brother Levi if he's watching. What's up, dude? And I'll see you guys in the next one. Like I said, happy coding, or like I always say, happy coding. Love y'all. Happy Thanksgiving. Peace.